I'm happy that I'm here, coming directly from Germany, Sunday, so not directly. I stay with the POMOR students, and I was very happy that I can teach the POMOR student. I have the feeling they are very clever, nice students, and interested also in this, how to say, little beside science, which is focused on soils. But in any case, today I prepared a presentation concerning the pedodiversity. You all know biodiversity, and my opinion is biodiversity has a lot to do with the pedodiversity in our system. And on the second part, I will talk about the carbon pool or stocks, which are sequestered in these permafrost affected soils. And I choose our long-term Russian-German research station on Samolovsky in Lena Delta. So the result I present are mostly coming from Sebastian Zubritsky, who worked as a PhD student in my group, and also he was supervised by Lars Kutzbach, the other co-authors who worked on the pedobiology in Russia. And of course I would like to mention our research could not have been done if we don't have such nice cooperation over long years. I'm an old lady since 1992. I got introduced to the permafrost site by David Gilinshinsky, and I still remember him very well, and I regret that he is gone from our group and too early, but I still remember him as a very good scientist, and he was the one who introduced me to permafrost. So since 1992, I like to do my work soils in the far north, and I'm happy that I can, I think nearly a year, go as a guest with my students, with other colleagues, to stay in your nice, wonderful part of Siberia. So I will start. Let me start with what is pedodiversity, and I choose one simple definition given by Ibanez and colleagues. It means that it's the variability of cryosol in different permafrost regions as determined by its constitutions, types, properties, function, and the conditions under which the different cryosols were formed in the cryosphere. So if we talk about permafrost soils, you have to take into account that you are in a special environment under the factors of cryosphere. So I like it, and we was thinking how pedodiversity could be characterized in these cold regions, and you have four possibilities. I took this from my former PhD student. He's cleverer than me. He left the science and go in the economy, earning a lot of money, more than me, but in any case I still get a good connection. And we were thinking, what is the structure we can use for describing pedodiversity? We can use the genetic pedodiversity, which is based on the differences in genetic horizons. In this case, German classification for soils is very close to the Russian. We learned a lot by you, especially by Dokoshayev. And the taxonomic pedodiversity is another concept. There we use soil classes or soil types. In this case, we use this soil grade groups from the WRB, that means the World Reference Database for Soil Research, which is accepted by International Soil Unit, Soil Society, so I have to say. And then you can parametric pedodiversity, which depends on the properties, the special properties of different soils. And also you can try to bring soils together in the functional way. You know, many soils behave under different land use and environmental and climate change different. They have function for these other ecosystems. So we choose for this presentation the genetic and the taxonomic pedodiversity. Why pedodiversity is an interesting topic? I think it is. When I started in Russia, I had no real, there was no soil scientist who could exchange with me because I wasn't able to speak Russian, and we tried to get along with Russian colleagues, talking with hands and feet, but we managed it. But when I saw later this very overview of the soils and looked at the Lena Delta, we used this and see that in this scale there's no information, real information on soil. So we worked a long time on the Lena Delta, not only on the island, but on this small island we could do a lot of research and map these soils. And then I recognize for the many demands you need on soil information, it's important to differentiate the different scale. Yeah, and so I think we started to look for soils to offer them other scientists or people of the authorities to use this information to make a better knowledge about their topics. Yeah, we aggregated this and started with the Lena Delta. Why? It's one of the beautiest and biggest deltas we had in the Arctic. So if you take into account that it's more than 32,000 square kilometers, and a third of this delta is covered by water bodies. But if you look closer here, you can see, and this is a nice idea, concept given by Misha Grigoriev, and he divided this delta in, not he, but all the people who work in the delta. You can see there are different types of geomorphological units. We have this, starting with this list, we have this Pleistocene remnants. These are the yellowish or the orange parts. The oldest part of the delta, to be honest, they are not really belonging to the recent delta. They are rest of the Pleistocene landscape with a very ice-rich permafrost, very interesting sites here. And then we have the so-called big unit Aga complex, which so far I'm informed they are still discussing the development, and the genesis of this part, of the whole part, is still under discussion. But I like to mention my colleague Dima Bolshanov. He made had nice ideas and published it in Russia. I could not read it, but he promised to translate it in English, or not in German, but in English. So one day I will discuss with him about this genesis of the whole delta. The soil formation or the soil investigation we did on the green colored areas, the so-called Holocene terraces. These are the typical young areas of the delta, which are dominated by the pure polygonal tundra. I will show you immediately. And then we did the research on these light colored of the active floodplain, which is the biggest size beneath the biggest size of the delta. So you have to take into account where you work. I would like to present some of the results we worked on the Aga and the Holocene terraces, and also of the other Pleistocene units. So that you see the northern Siberian Lena Delta River, concerning the climate, factor climate, is very close. If you look here at the Duna Island or at the Stolp Island, you see the pattern of the climatic factors are very similar. The average negative temperature, the small amounts of precipitation, about 230, and also Tixi we included here, which has the same temperature regime over the year, and a little bit more than 100 millimeters of precipitation. But I think these are very representative climate data, to understand how the soils here are developed. So let me starting. It's good enough with the light. Maybe we should switch off the light. Then you have more. You could see more of the. Could we? Yeah. So we need it for the record.
Yeah, it's okay.
Yeah. I don't know. Maybe the other slides, soils pictures should be seen at the dark. Any case, what you can see Here is this polygonal pattern ground of Samoilov Island. You see this nice low center polygons of the first river terrace, and you see these degrading polygonal tundra getting ponds in the centers, little ponds, water bodies, and bigger and very big thermokarst lakes and degradation part. And here, just in the background, you can see Stolp Island, which is built of pure calcareous rock. So we have these nice young floodplains, this first terrace. And what kind of soil we have? Taken a section through such a polygonal structure, then you see at the polygonal rim, and also in contrast to the polygonal center, that we have really different types of cryosols, which are here are classified by the WRB, this international accepted reference database. And you see that these soils on this physiological drier part of the polygon structure have a lot of carbon in the upper part, and also this was only digged up to the ice of the ice wedge. So the soil can divide it in three components. The upper part, which is always getting thawed during the summer period, it's called active layer, but it's more than an active layer, which taking into account only the temperature regime. Here we have the soil formation, the horizon formation, the translocation and transformation of, for example, organic substances. Also oxides could be formed in this region. Then we have the permafrost table lying here, and then starting the rest of the frozen ground or the frozen part of the soil, and then directly connected with the ice wedge. And so because of this characteristic, we call the soil glacic, connected with the ice, turbic, because there's a lot of cryoturbation, cryosol. Yeah, that is very nice. Also in Russia, they could go in the group of the cryosames because of cryoturbation. So it's a total different soil we have in the center, and the center are the most biggest amounts of these polygonal tundra. We have a nice soil which is dominated by the organic carbon pool or carbon in the upper part of the soil, which drops down, increase, that's normally, but there's still a lot of carbon also on the top of the frozen part. On the permafrost table, we have enrichment of dissolved organic matter here on the deeper part, and as you can follow here, we only digged up to 70 centimeters. In this case, we are more lazy, only digging up to 64 centimeters, but it's soil which has a normal stratification under an O layers. There's a little bit organic material which is enriched on the upper centimeters, but too small to name it by an own horizon, followed by the different water influence B horizon. So it's a happily histic cryosol. The important thing is standing here. We have a histic peaty, little bit like peat accumulation in this cryosol. So now this were the main important soil, or we can say soil complex here on the Holocene river terrace. Now we switch off here. It's only maybe a half a meter, or in some cases more than 1 meter, getting to the active floodline. You can see here. Here is the old station of Samoilov. I'm sure you could not see it. I think it depends on the light. Sorry for this. But any case, here is the new building ground from the new Putin station, which is running since last year. Big station for a small island. Let's see what's going on. But now the active floodplain with also very nice soils, but totally different. These soils normally have no pattern ground, or they are not included in pattern ground. There are some pattern grounds, if they are drier, like this one, you can find ice wedges. But in this case, you see concerning the carbon pool, the idea of this talk is to present you the carbon which is stocked in these little part of our world, on the Lena Delta and also in Samoilov. And you see there is normally distribution of organic matter starting with high, directly by organic matter coming from the grassland or for the natural, here that's cotton grass we have, and then we have an decrease of carbon with the soil. You see this or swallow acid reaction, but it all nice profile which could be named fluvic clay cryosol. The clay is here the dominant feature you can see in the whole profile. You have water influence, that means formated iron oxide will distribute it in the whole profile, and the permafrost is starting here at 40 to 60 centimeters. And the other one is the drier part of the floodplain. We have areni, that means very sandy soils with fluvic sedimentation rates. They are dominated not by soil, really, by soil formation factors, but in the deeper part. But they are covered by sands, which are dominated by the sediments here, coming by the Lena. Only in the upper part we have an enrichment of organic matter, and if you hit former land surfaces before the Lena brought all the sediment, you have the former upper horizons with a lot of humic. For example, this deeper one was 1.6 or 2. So it's typical for these alluvial sediments. But because we have permafrost in the upper 1 meter, permafrost starts at 75 centimeter, we call them also cryosols or cryosols. In the Russian system you would not call them cryosols. It's a primitive soil generated post-synlithogenic with the sedimentation of the Lena river sediments, but after international we saw this areni fluvic cryosol because of the feature we have in the bottom, permafrost, and the little formation of special structure and humus accumulation in the upper part. But maybe we can discuss later if this should be corrected by the Russians or by other persons. And now I hit off to the Argamoisis complex. You see that from Google a picture which shows permafrost and affected landscape dominated by sands and a lot of little lakes and big thermokarst lakes. And these tundra, it's a tundra, looks not very nice, but if you go closer you find also a good vegetation, like tundra vegetation without trees, dominated by grasses and small shrubs, by small vascular plants. And the soil we have are also, if you look at this picture, you can see very clearly cryotubation is one of the pedogenic process which is going on in these soils, and therefore it's a cryosol because we have permafrost in the upper 50 centimeters, and because there's cryotubation, especially in the upper part where you can see clearly the churning and the mixture of the former horizontal orientated horizons getting mixed. It's a turbic cryosol, and because it's dominated by sand, it's an areni turbic cryosol. And if you look at the carbon, because later I would like to present you the carbon stocks, you see there's typical enrichment in the upper part, of course dominated by the fresh litter which was incorporated in the soils, and you have a normal increase, and in deeper parts where it gets accumulated organic matter by cryotubation, you can also have deeper or higher organic matter contents or organic carbon contents up to 1.3%. Otherwise a very acid soil. And on the other hand we have also cryotubated cryosols which are dominated by more accumulation of of organic matter due to the higher aqueous conditions. So this goes to an equatorial cryosol, and if you look closer, you see that the A horizon has a lot of carbon, and maybe we described it not correctly during this trip. We had only 2 hours for the helicopter to be there. All the others made their measurements, but the soil scientists get never enough time. So we looked at it and decided it's an A horizon, but after looking at this, analyze it, this is the organic carbon content, but if you transfer it with a factor 2 to the humus content, you see that's more an O material. I would change it, but this was the situation we came from the field side. Yeah, that's the most important thing. Now let me switch off to the parts from the old Pleistocene mainland remnants we have in the southern part or southern western part of the Lena Delta, rest of these older Pleistocene landscapes. And as you can learn here from this picture, you see a lot of ice-rich sediments, and a lot of erosion thermokarst channels and canal erosion parts, and we investigated on the top of the plain, going on the slope, and in the deeper depressions of the high plain we looked for the different soils. Yeah, the detail on the investigation areas was this part of the so-called Kurnyach Island. It's not far from our station or from the station Samolov. You can easily take the boat, also a little rubber boat, and traveling here. The guys which worked with for my group, that means the master student and also the PhD student, had with Russian colleagues here a small summer camp, and they stayed there because it makes no sense to travel 1 hour every day back to the station, so they had the fun in the real field tramp, and they investigated this tile concerning the pattern of soils and also taking samples for the carbon pool and nitrogen pool. Yeah, here you can see the first map from this detail of Kurnyach Island. And what you can see, the green colors here are the plain part, which are dominated by polygonal tundra and sort of hummocks. And as you can learn here, I will explain later, but you can see that it was not able to distinguish all the different soils, so we named them soil complexes and combined different qualities we found here on the plain. Then we investigated the so-called slope, which is now here the area distribution here on this in this pinkish color, and then these color from the depression, from the Alas depression. We had also different very wet organic peat dominated soils. Yeah, this is an impression from the ice complex. You see polygonal tundra. Hopefully you see this is the center, low center, with a lot of sedges, namely dominated by Carex aquatilis, and then you have these round higher levels of the ice wedge rims, also with cracks, so it looks like Lena, like the Samoylov Island, but not so prominent. So these seems to be older. So what kind of soils we have? Divided polygonal rim. Compare this with the center of the polygon, and you can see here very low permafrost table. That means in the end of August, or in the maximum of the vegetation period, you had only 23 centimeter active layer. A very wet condition, very reduced conditions. No oxidized iron components. All the iron is oxides are reduced, so we have a strong cryotubation which mixed all these upper parts of the O layers to the directly in the B. You couldn't recognize a real upper A horizon. And concerning the carbon content, you see the high carbon in the upper part going down in the mineral part, but at least we digged only 33 centimeters, and later on we drilled on the same sites and got the information up to 2 meters. But I will talk about this later. Now it's pedodiversity, the topic, and we have in the center another type of cryosol. It's dominated by histic and also of water, and you can see it clearly. There's a lot of carbon in the upper 35 centimeters in the soil, and there's a difference between. And under the point of view of upscaling, you have to take into account how much of the area is covered by the center and how much is covered by the rim, and this ratio gives you the good right number or the proper number for the stored carbon. Now this picture show you the little mounds, hummocks or tussock, you can melt. This is the slope side ending in the deep depression, Alas depression with the lakes. It's here the purple one, and the soils are also very nice, cryotubated soils, dominated also by water. We have a lot of carbon here, and they are very wet and strongly cryotubated and heavily to dig because they are of loamy sand, and loamy silty sand is more heavier, and also the carbon represents a big pool. And then we have on the mountains of the hummocks, we have the cryosol without cryotubation, but cryic features, very cold features, and you see the enrichment of carbon in these soils are not so prominent as the carbon in the depressions of this hummock structure. Immediately we change, getting in the thermokarst depression, and here we have different kind of very wet soils. They're hard to work there, but the youngsters, in the first year I accompanied them, and so I know what they have done over the year, and because I could escape after 1 week from Courignac and do other jobs, but I know what they have done, the boys. And here they also have cryosols which are dominated by peat accumulation. You see it clearly here in the organic carbon content, and also cryotubation in the upper part via the organic dominated, and the lower part of the B horizon. And you also see there's a lot of carbon via cryotubation located in deeper parts, and you have a lot of carbon in the upper part, and also in the polygon center, and this was the rim, in the polygon center you have a lot of carbon here over, it's more than peat because it's generated in wet conditions. So this should be peat in our system. In your system, I don't know, I think you also would give other horizon names, but according to the WRB system they get O, and you see a lot of carbon which is stored in these thermokarst depressions. These were the soils. Now here you see the diversity of these soils, and I think the variation of the soil carbon in the Lena Delta is a good basis to think or make it difficult to calculate how much carbon is stored. And why this question is important, many people who work on permafrost and look at the distribution, and also the International Panel for Climate Change indicates with all their publications that especially in the area of the high Arctic and also in Russia will be expected distinct increase by the temperature, by air, and also of the permafrost up to the year 2090. And I think many of them came to soil scientists and asked, could you say how much carbon is stored in the permafrost? I'm sure that also in Russia you had to answer these questions. And because I'm working in the Klima Campus area, University of Hamburg, the modeler normally tries to do not contact with people who do the observations and investigations, because then they have problems to simplify what soil scientists or geologists say. But in this case they came and said we have to work together. Yeah, and they are mostly interested in the carbon pool. And here's a nice picture I took from the work by Christian Beer, who made a simple model scheme about what will happen starting from today and looking at future scenarios, what will happen to the permafrost. Nowadays we have about 191 petagrams of carbon stored in the upper part, in the active layer, which is here defined as 0 to 5 centimeter. Of course, you learned by the soils I show you that not all of this is really active layer. And we also added the nitrogen pool, which goes 6 petagram. And if you're in the permafrost stored, you have a lot of carbon in the frozen part, more than 800 petagram and 28 petagram nitrogen in the carbon, in the frozen ground in permafrost. And they predicted when the future warming goes on, the active layer will rise in thickness, the permafrost table is dropped down, and the active layer is rising, and the pool will increase in such numbers up to nearly 500 petagram will be available, and the permafrost, of course, still have a big of pool. And what will be happened with these additional available carbon pool, which is now under good conditions for mineralization. And so it was predicted. Nowadays we have a small amount of trace gas release or carbon and nitrogen sinks here in the soils. This should be changed by temperature driven processes. So this was the idea, and then we collect all our information we had, starting up with this little island. It was so important that Putin visited the stupid island with us, or but the result was we get a new station here. Yeah. So, any case, we had this coming from the information we had. Now you look here, we did this in former days using the American system. If you look here, it's a very specific name, but they could be also retyped in the WRB, or of course in the Russian system. We worked here together with a Russian soil scientist, and then we know from all these value sites we did on Samoylov, we had the information, and we could calculate the organic carbon in kilogram per square meter for all this unit. And this was the first step we did, and saw that more than 70% of the island has these bigger amounts. They are vary between 33 up to 44 kilogram per square meter, and also the sandy sides of the floodplain stored carbon up to 70 kilogram per square meter. So this is the, key site, or the validation site. We can, with the information of these sites and additional the formation of the soils and additional, drilling, this colleague Sebastian Zubritschi has done during his first part of his PhD thesis. Now he is postdoc. He used a special driller to get the deeper parts of the soil, which we needed for the calculation for 1 meter depth. And if you can see here, the quality of this auger was very nice. We got a nice core and separate it in the different zones, and do good investigation on soil, on carbon, on nitrogen, and on sulfur and phosphorus, different kinds. And the result, it is hard work. You see, this guy was by manpower doing it, and you only can reach up to 1 meter. But he managed it, and we had this information here. Small graph, what to say, we divided this information we have for the river terrace and the active soil plan. And here was the idea, for the upscaling we have to reduce all the information we have on the soil type, where we have the measurements, to aggregate to the two most important geomorphic units, which means the river terrace and the floodplain, because these are the units you can see via satellites and air pictures using GIS to use this for the upscaling. So we took first the gravimetric organic matter, which has the content in percent, and you see the influence of the gravimetric. We have a lot of carbon in the upper part, and you see here on the top, this is the same scale. We differentiated 0 to 2, 8 to 10, these different deep samples. And here we did the volumetric content determination in kilogram per square meter. We need this for the upper scaling. So it was a nice job, a lot to do, but in any case it was helpful because now we could start get the information by the satellite pictures. And you see the quality of this picture is very nice. You can see the agar complex, you can see the remnants of the old Pleistocene units of the lead delta, but there was no differentiation between the alluvial sands, which are lower concentrated of carbon, and these floodplains. So the first thing Sebastian did, he differentiated land and water bodies, excluded it, and then he was able to exclude via the analysis of the remote sending the unit. We didn't have so much information, the agar and the Pleistocene floodplains, and we could now, where we had a lot of data, calculate and upscale the Holocene river terrace and the active floodplain. We got a lot of information on it. And this was the result. Here for the Holocene river terrace, very proper work. And these are the amount of carbon stored for these different layers. And in this column you see the calculated or added for the upper meter. This is about the 0 to 2. This is the amount stored with 0 to 10, this 0 to 30, and so on. This is the whole amount in teragram of carbon in this Holocene river terrace, which the whole area of the delta counters 4,090 square kilometer. And the same we did on the floodplain. We know the information we had, and if we calculated the whole 0 to up to 1 meter, we got nearly the same number because it's a bigger size, low carbon content, but bigger size for these two very important units. And that you see that we did it properly, could you see at this validation of the upscaling stock we found in this in these two units. We had some information of the remnants and also of the agar complex, but only we had this nice big set of data pack set for the ground truth data for these two units. And so we had this information from the picture and could go in the field because we stayed there and could correlate the examples of the ground, using them as ground truth data point for both sides, for the Holocene terrace and also for the floodplains. And so we had a good feeling for getting this upscaling in this field. It was a very nice job done by Sebastian Zubriczki, and he published this in a good journal. Yeah, how to summarize? I hope you can follow me and not so exhausted at all. I can now show you, talk to you how we worked on the carbon part. We also did it, of course, because we had samples for nitrogen and did it for sulfur and phosphorus. And we could say that the estimates indicate that the Lena River Delta contains within the Holocene river terraces and the active floodplain a lot of carbon, which is counted 240 teragram of soil organic matter. And if you take the nitrogen into account, we have 12.5 teragram nitrogen in the upper soil. So we have a huge potential, which is viable immediately if you want to use the soils or you want to let them as a nature reserve, everything you can use this. And of course, if you look closer of this stock, 114 teragram soil organic carbon, and the same range 6 teragram carbon. This means 47% are situated in the depths between 50 and 100 centimeter, and that means that are currently they are blocked in the perennially frozen ground, in the permafrost, and it's a real good number as a basic for further investigation from different topics, from different point of views you would like to take care. Yeah, and I think this, with some conclusion, I want to finish my presentation for you. I think the Lena Delta Reserve is characterized by a high bio and pedodiversity. It's a wonderful place to go there and study, not only for soil scientists. It's a good place to work interdisciplinary. The different cryosols are beautiful. Of course, they are endangered. And natural bodies of our Arctic system, we have to take care for them. It's not, soils are more than dirt to push with the feet on. You see they are real own ecosystems if you look from the point of view of the plants and the organisms who manage these big pools and store nitrogen and carbon and phosphorus in these very pristine areas. These studies about pedodiversity of cryosol provide necessary data sets for upscaling of any kind of elements, nitrogen and carbon we started, but you can also have the other information and the evaluation of ongoing changes in the environmental and, if you want, also the climate condition in permafrost. Permafrost is defined by temperature, so climate warming will affect them, and how people will take it and what they interpret them, we will see later. A robust prognosis of the impact of climate change on cryosol are based on proper field, lab and model analysis. And I work with modelers together, and sometimes I feel they could more listen to these people, to the observing. In any case, it's getting better because these analyses are irrelevant for the soil processes and the function of the soils in these permafrost affected landscape. You are lucky, we are finished. Thank you for your attention.
Thank you. Yeah.